Hello friends, in this video we are going to learn life cycle of an activity. In Android application, an activity performs a major role. Let's discuss the activity and its life cycle. On our standard desktop machine, it may be Linux or Windows, we can run many applications and these applications are visible at once in different windows, in the form of different windows. But at a time, there is a focus to only one window and it is active. All other windows are just residing at the background. So at a time only one window is active and we can switch amongst all those windows as and when we need. But in Android, the procedure is something different. Android does not work in this way. So what is that? What is the difference here? In Android, there is a one foreground application which typically takes over whole display except that the status line. So only one application is running and which takes or which covers whole screen. Here, when user turns on their phone, the first application they see is the home application. But when user runs an application, Android starts it and brings it in the foreground. From that application, if user might invoke another application or another screen in the same application, then this another application becomes a foreground application. So all these programs and screens are recorded on the application stack. It's like web browser's history. So when we press back button or back icon in a browser, it shows us the previous page. Similarly, the application stack records all those activities which different applications or the screens are opened. So when we move back, it actually this application stacks helps us to show the previous windows or previous applications. This is all managed by the activity manager. At any time, user can press the back button and the previous application can be shown. From the user's point of view, it works as a web browser. Here, but internally, each user interface screen is represented by an activity class. Each activity has its own life cycle. An application is comprises of one or more such activities plus Linux process which contain them. So have you understood what is an activity? Whatever the user screen at a time we see, it is implemented as an activity class. A single application may have multiple such screens. So user can navigate those screens. So this Android application is made up of one or more such activities along with the Linux process which takes care of them or contain them. We find the definition of application is pretty simple, but see the next concept, which is pretty we find this pretty straightforward, but it's somewhat difficult. But not to worry, let's see in detail. In Android, the activity of lifecycle is not tied to the process lifecycle. See here, processes are just disposable containers for the activities. Understood this one? Let me repeat. Activity lifecycle is not tied to the processes lifecycle. Here, and the processes are just containers where the activities are maintained. But what about an application? Application can be alive even if the processes has been killed. We as a processes are just disposable containers. So this is probably different from every other system to which we are familiar. So let's look a brief or detailed look on this particular topic. So what is the conclusion here? Here processes are not equal to an application the way we think or studied in other operating system like Linux or desktop machine. So let's have look on life cycle. So let me show you the life cycle diagram for an activity. See here, during its lifetime, each activity of an Android program can be of several states as shown in the figure. We as the developer do not have any control over what state our program is in. That's all managed by the system. However, we can get notified or we can get an idea about all the stats from activity is moving from through which by calling on XXX method, like on create, on start, on resume, on pause. If we call such methods, then we can get identified when an activity is moved from one state to another state. See, the, the rectangle shows the states of an activity like starting, running, pause, stopped and destroyed. When any activity moves from one state to another state, it performs some actions. Like these actions here mentioned, when any activity moves from When any activity moves from starting to running or whatever may be the state, it performs some actions. These actions are mentioned in a sequence. Like when it moves from or the state changes from starting to running, then it invokes different methods like on create, on start, on restore instant state and on resume. So here this on restored instant state is an optional one. When we want to identify when a state is moving from starting to running, we can invoke these methods and we can confirm about there is a move or there is a change from one state to another, that is from starting to running. So let's have a look on every different methods that we can override, and the default implementation is also given by the Android API. So let's see the meaning of on create, on start and all other states. But before that, let me show you or let me tell you which are different tasks performed. When activity state changes from running to pause, the on pause, this method is going to be invoked compulsory. Then from from pause to stop, there will be a on stop method called. From stop state to the running state, then in a sequence on restart, on start, on resume, these methods are invoked. So any one of the method you can use and cross check whether there is a change from stop state to the running state. So let's have a look on all these methods in a one by one, and we will come back to this diagram again. Look, on start. This particular method, it indicates the activity is about to be displayed to the user. So when at very first time we click on an application, the first launching activity is going to run and it invokes the on start method. Then we have the on resume. This method is called when your activity can start interacting with the user. This is a good place to start with, to start animations and music. Thirdly, we have on pause method. This runs when an activity is about to go into the background, usually because another activity has been launched in front of it. This is where you should save your program's persistent state, such as database record being edited. So this is the right place to save the data. It may be possible that from on pause state, the activity or the application may get destroyed. So before terminating the application, the status of the data need to be stored in a persistent state. That's why the storing of the data is made, or it is recommended to write some persistent state storage in a on pause method. Next we have on stop. This is called when your activity is no longer visible to the user and it won't be needed for a while. So if memory is tight, on stop may never be called. Simply our process is going to terminate. The next method is on restart. If this method is called, it indicates our activity is being redisplayed to the user from stop state. As I mentioned previously, look, from stop state. If our application is about to run, that application will come in a foreground. At that time, on restart method is invoked. Next, on destroyed. This is called right before our activity is destroyed. Look at here. You may be in a pause state or stop state. Then, if our application is about to terminate or kill, then on destroyed method is called. But look, I mentioned previously, from pause state, our application may be destroyed immediately by killing that process. But when we are at, or the activity is at stop state, then on destroyed method is invoked when it is about to terminate. The last two methods are very important: on save instance state and on restored instance state, and the parameter is bundle. This bundle is nothing but actually the state of the program or the state of our application. On save instance state, here Android will call this method to allow the activity to save per instance state, such as cursor position within a text field. Usually you won't need to override it because the default implementation saves the state for all our user interfaces, which are controls automatically. Similarly, we have on restores instance state. This is called when an activity is being reinitialized from a state previously saved by the onSave instance state method. The default implementation of this method is also present. So just we need to make use of it. Whereas the previous method, that can be overridden and we can have our own implementation. So this is what the life cycle of an activity. So I hope you have understood it. So let's have a brief on it. When application is about to execute, then on create, on start, on resume, these methods are invoked. It goes in a running state. It may there for some while, and because of few reasons, or like another application is about to run, then it moves to the pause state. From pause state it goes to the stop, and then it may go for running or destroyed state. So this is what the life cycle of an activity. Remember that it is not similar or not like to the process life cycle in Windows or Linux operating system. I hope you have understood. Thank you.